Hello, welcome to Build Day Live. I'm Jeffrey Powers. Today we're going to have a good old-fashioned bake-off. But in this bake-off, we're going to be using enterprise servers instead of cakes. More to the point, we're going to be looking at the AMD EPYC processor in the server room. Now in this video, we're going to show you the 4th generation EPYC processor, the Genoa line. The scenario, you're in a data center and your company needs to replace a server. You have a limited budget and the need for a powerful processor that's also energy efficient. Your server room is also one brand of processor, but it's time to look in new directions. The server in question is your VMware vCenter server as the device needing upgrade. All your VMs are on separate storage, so we simply have to spin up the EPYC server, bring the vCenter server over to the EPYC, then plan for the decommission of the current server. With that, let's get started. First of all, let's understand what we're installing to replace this old hardware. This is the 4th generation EPYC 9004 processor installed in a dual processor unit blade. We'll be showing you the unboxing a little bit later in the video. This state-of-the-art processor, built on an innovative Zen 4 architecture, delivers unmatched computational power, scalability, and security features. The Genoa we're actually going to be using has 96 cores and 192 threads, but EPYC processors can get up to 128 cores and 256 threads. The EPYC 9004 is engineered to handle the most demanding workloads, from AI and machine learning to cloud computing and big data and analytics. Its energy-efficient design significantly reduces the total cost of ownership, making it the ideal choice for forward-thinking enterprises. Here are some of the important features that make the AMD EPYC 9004 processor superior to others on the market. Like we said before, it has a higher core count, up to 128 cores, as opposed to the 60 from the competition. Advanced Zen 4 architecture delivers improved performance and efficiency. The higher thread count supports up to 256 threads with 5 nanometer manufacturing process for better performance per watt and greater transistor density. Higher base and boost clock speeds, greater energy efficiency, integrated AI and machine learning accelerators, extended memory capacity which supports up to 4 terabytes of DDR5 memory per socket, enhanced security features like secure encrypted virtualization, SEV, PCIe 5.0 support offering higher data transfer rates and improved I/O performance along with CXL support, advanced thermal management, and, well, the list goes on and on. But one important feature is the better price to performance ratio. That can give you a more cost-effective server for the performance delivered. Now, before we get into this, I do have to mention Build Day Live is being sponsored in creating an independent comparison and showing you how you can install into your data center. All opinions are that of Build Day Live. If you have any questions, you can contact us for more information via Build Day Live, or just basically leave a comment at youtube.com/Build Day Live. Now let's go ahead and find out a little bit more on the stigma of mixing an environment. I had a great conversation with Greg Gibby, a senior product manager at Data Center Products at AMD. All right, we have here Greg Gibby from AMD, and he's going to be explaining a little, because we're talking about how AMD can outperform the competition. So let's get some more detail as to why AMD makes this claim. So Greg, you're the perfect person to ask this question to. Let's talk about the effect here. What happens if somebody takes an AMD system and puts it into a non-AMD architecture enterprise?
So first of all, I kind of want to talk on that piece because when we talk to customers, there's a lot of times where there's a little bit of misunderstanding around that piece where you say, hey, you put a new architecture. When we talk about our architecture, we've done some really cool things when you look at the chiplet architecture. That's allowed us to drive better core counts, to disaggregate kind of like the chip to make them a little bit smaller so we can improve our yields. We can drive the process improvements faster. We're on 5 nanometer, moving to quickly to 3. And those have allowed us to drive huge performance gains in terms of total performance per socket, as well as performance per core, and at the same time, driving better energy efficiency. Now, that architecture is the same x86 architecture as Intel, right? And so we're not straying from that instruction set architecture or the ISA. All your applications just work. And so when you hear, hey, AMD's got this new innovative architecture, it's still x86 based, and your core applications are just going to work with AMD. So I kind of want to make that point up front. The second thing, when I talk to a lot of customers, is I don't have the time, the money, the energy, the resources to evaluate AMD. You guys might be great, but I don't have the luxury of taking a look at AMD and then moving all my installed base over to this new AMD. And a couple things I wanted to talk about on that. And again, we just set the groundwork there that it's x86. So it's not a huge shift. You're just moving from a monolithic architecture to a chiplet architecture, but the software doesn't know the difference. When you look at any time you make an upgrade, so if I've got an installed base of 4, 5, 6-year-old servers and I want to upgrade them to the latest and greatest, even if that's going from Intel to Intel, you have to do work. You've got to go look at updating all your BIOS. You've got to update your drivers. You've got to run this thing in a sandbox and test your software stack and make sure everything works before you put it into production. You have to do the same thing on AMD. And if you were going to move from Intel to AMD, you have to do that same amount of work. And so the big difference, though, is when you move from an older Intel generation, so in this case, we're showing either a Cascade Lake or an Ice Lake generation to the latest and greatest Intel, your benefits are not huge, right? You're going to see performance uplift, yes. You're going to see power savings, yes, but they're pretty small. When you move from that same older Intel generation to the latest and greatest on AMD, those benefits are exponentially better in terms of the performance per socket, the performance per core, the performance per watt, that energy savings across the board. You're going to see a substantial benefit of moving to AMD over what the competition has. And again, similar amount of work. So if you're going to put in the work, it makes sense to do the one that's going to give you the best outcomes and drive the best benefit for your business, both short-term and long-term.
It's an interesting slide there, but I do have to ask the question, what type of benchmarking have you done to figure out that this is actually the case, that we get a better benefit across the board?
Yeah, that's a fantastic question. And the answer is a ton, right? So when we look at the benchmarks, right? So there's the spec benchmark, spec in, spec FP, spec power, spec JBB. We have leadership on all those. When I kind of go to virtualization benchmarks like VMware, leadership there. When we look at database and database analytics benchmarking, HammerDB and the TCPX H and TCPX DS, et cetera, leadership there. When you look at SAP and you look at the decision support with the SAP, leadership there. And all the HPC benchmarks, right? So when you look at it, it's not just a couple isolated benchmarks that we're calling out here. It's really across a broad range of benchmarks and applications across HPC, general purpose workloads, database and database analytics, virtualization, et cetera. So across a broad range.
Let's talk about possibly real case uses, having somebody that's actually doing this switch into the AMD architecture. What have you guys been seeing or hearing about how that's been going?
Yeah, and that's another excellent question. And we actually have, I want to say we're moving up close to 150 some odd customer testimonials that we have out on AMD.com. And there's a number of those that talk about the benefits of moving from their currently installed base to AMD and what they see in terms of consolidation, in terms of their power, cooling, and actually space footprint, performance gains, et cetera. And I think one I would call out is one that is, I think, fairly representative of a lot of them was Emirates Bank. They were having a challenge where they would run these big batch jobs overnight and they weren't finishing in time. And so they, in the morning, people would come in, they need to start doing their work. They didn't have the data they needed to do that because they were unable to finish those batch jobs. And at the same time, they were looking at trying to go make a transition to take better use of containers and move into a more cloud native type of workload as they were looking at where they were moving their strategy into the future. And so they took a look at AMD and said, hey, look, what could we, what does AMD bring in and what could happen here? When they did all their testing, they found that with AMD, they would see a significant performance benefit over the competitive solutions they were looking at in terms of driving better performance. And it also provides the flexibility to allow them to do those cloud native workloads and drive to that containerism strategy that they had as well. And so, they made the switch. And now they've got extra headroom, actually. Batch jobs are finishing on time. They make sure that they get better productivity from their employees because they're not waiting around for data. And they've actually got headroom to add more given the performance-based increase that we saw there.
The external customer base is also affected by that. And I know if I was a client that
absolutely.
I want.
Huge benefit to the business.
Yeah, absolutely. All right. So I do have to ask the question, the benefits of AMD to AMD on an upgrade do we see that, or if somebody was to try and switch back, or?
Well, I wouldn't recommend switching back. I think that would be a move in reverse. But yeah, I think when you look generationally, absolutely, with AMD, we've seen huge benefits from our first gen. I think we've more than doubled the performance when you look at going to our second gen. And, the innovative architecture that we've driven with that chiplet design has allowed us to continue to drive really solid performance and power savings generationally as well. So, yeah, if you were to go look at, if you bought a bunch of our second generation and installed those, they're still great. They're still doing a good job. But when you compare that to our latest and greatest, our fourth gen, yeah, there's some significant benefits on all the things we talked about around that performance at the socket level, performance per core, performance per watt.
Now, you talked about earlier about people being hesitant on going and switching, adding an AMD infrastructure into their enterprise. Once they get it in, I guess the next question, and of course, we all know that it's all about scale and everything like that. Does AMD have a plan for clients to go where they start with one appliance and then they move to the next and they move to the next until they are all AMD?
Well, that certainly could be enabled. And you say appliance, it's really isn't like a Nutanix or a VX Rail limited type of thing, right? You can do this with general purpose or clusters or individual servers or whatever. But yeah, I think what we've seen, right, is most customers will try this in a small area, maybe within HPC, electronic design automation or something, where they've got a specific need, and AMD just brings extremely high benefits to that particular workload. So they'll try it out there. And what we've seen is more times than not, they're like, wow, the benefits that we see here are phenomenal. We need to get the rest of the business on board because of, again, all the benefits they see around that extra performance, the power savings, the ability to consolidate workloads, et cetera. So yeah, we see that with customers where, again, they try it in a small area, they see the benefits, and then they rapidly try and, spread that to other areas of the business so that they can see the benefit as well.
All right. Well, this is Greg Gibby. Greg, thank you very much for your time and helping us understand a little bit more on the benefits that you get for switching to AMD.
All right. Thanks.
Now let's focus our attention on the machine itself. For the transfer blade, we'll be using the EPYC 9004 dual processor. Inside, it has dual power, multiple NIC capabilities, but for this project, we'll be only using one NIC and a single hard drive running ESXi inside there, as all our VMs are going to be on another machine. Here is the unbox. What we're unboxing today is the 2P Genoa SP5 server from Supermicro. It's powered by AMD's 4th generation EPYC processors. These servers support AMD's EPYC 9004 series processors, which can feature up to 96 cores. This setup allows for substantial processing power and rapid data handling. A key feature of these servers is the support of PCIe 5.0, which enables higher data transfer rates, which is crucial for data-intensive operations. Additionally, they're configured with DDR5 memory, enhancing both the speed and the power efficiency. The SP5 platform itself is designed to accommodate dual processors and features a robust thermal management system to support the CPU. Now, with that said, let's go ahead and get this unboxed. Got most of it. There we go. All right. Inside here, looks like another box. And inside here, we have the unit. All right, we're going to start with, you got some basic speed rails right here for your rack. We're going to set them off to the side though, because we don't need them right now. And then we have some foam with some boxes in here. We're going to take those out and then set the foams to the side. Next up, we have the rack itself. So go ahead and pull out, just like so. And we're going to gently set it on the ground. That wasn't easy. And then we'll go ahead and get rid of this box. I'm definitely getting a workout today. All right. So we set this like so. We'll be able to get the plastic off here. This is mostly a two-person job. These are not light. There we go. Perfect. So what these are actually, I thought these would be railing, but what these are CPU thermal heat sinks. So of course you'll have to apply the thermal paste. We need these. So let's go ahead and put those to the side. And we're going to go ahead and open this up. It's basically pressing the blue button and sliding the handle, lifting up, bringing out from here. Inside here, we have several pieces. Let's take a look at the front and the sides here. First of all, we have where our processors go, and we have where our memory is going to go. So that's all set up here. We're not removing any of this plastic covering right here. Each of these right here are fans. They're definitely going to be blowing the heat and the controls. Go ahead and look at one of the drive bays here. It's a simple drive bay. Takes a 2.5-inch drive, of course, SSD drives, and then goes in and pulls out. It looks like, there we go. There's one with an SSD inside. This is a 1.92 terabyte SSD right here. Got an empty bay here. I think that's the only SSD out of the whole thing here. Yep. All right. So we've got 8 bays, and then the first bay is, I'm assuming that's where the main operating system is going to go. And then, of course, your extra storage is going to go into these bays. Now, the memory, let's pop one of these off and take a quick look at some of the memory here. This is one of the memory modules. This is 32 gigabytes of memory. And what we've got in here is we've got 6 bays on each area. So 6, 6, 6, 6. So that's 24 different bays. And then, of course, the processor, we're not going to pull this off because it's probably got thermal paste all over. We'd have to reapply it. But as you can see, that's the configuration for this area. I'll put that back on. There we go. Let's turn this around and take a look at the back. So on the back, we have 2 power supplies. They pop out. Yep, they pop out like that. There we go. And then they can be easily replaceable if you need to. Next up, we have the PCIe bin right here. So if we pull this up, there it is. There's our PCIe. This is basically the dual Ethernet card. So we got the dual Ethernet card right there. And then, of course, the PCIe slot riser. It'll go right into this slot right here. There we go. We'll pop that back out because we want to show you this. This is the other PCIe bin area. It takes 2 more PCIe cards, so whatever you need to put in there, you definitely can. Let's go ahead and pop that back in. And then we'll go and pop this in. On the back here, we'll have a standard VGA port and a couple USB, and then another Ethernet that's hardwired into the system. Now, when we're done, go ahead and set that out. Put that down. Get our blade cover. And by the way, the cover actually shows you everything, where everything is. So if you have any questions, just pop off the top and then take a look on the inside. It'll tell you everything that you need to know. And before we also put it on, you'll notice right here, this is the chassis intrusion button. So you'll know if somebody's actually been in your machine. There's a couple different pegs on this back here that go into slides. So we'll bring that in. Set that down. Line these up. There we go. These in. And then there we go. Snap it in and it's good to go. If it doesn't come down, then you've got something loose. Open it back up and make sure that these are secure down. This is secure down and these are set in. Otherwise, this will not close on. So once again, we align the pegs. And then as you can see, that just snaps down like that. All right, so we spent a few days putting everything together. We got our legacy machine set up with all the VMs and the vCenter server. We got our AMD machine set up and turned on. I also did some power-up tests on the machine, which was fairly comparable to the legacy machine. You might actually hear it in the background because it's literally right over there as we go ahead and move over these VMs. Let me show you what we got here. Basically, we have our 2 machines as 2 different clusters. Legacy cluster is the old machine and the AMD cluster is the new machine. We set up IP addresses on them and now it's time to move the VMs over. It's basically drag and drop as long as the VMs are turned off. If not, you'll have to do a proper shutdown and verify the VM service is completely off. Like I said, we have the legacy cluster and the AMD cluster. We're going to choose the AMD. It says that all the compatibility checks succeeded, and then we're going to go ahead and hit next, next, and finish. And now VM001 is on the AMD cluster. The vCenter server is still on the legacy machine at this point, but you could open up VM001 from the AMD side without a problem. Now we're going to go one by one and bring over all of these VMs to the AMD the same way. There we go. We have it all set up and, well, out of full disclosure, as I finished moving over the vCenter server, the power actually went out. So I had to make sure that all the VMs were still over on AMD, and after a couple reboots, I could access them. We were back up and running without issue. As you can see, all of the VMs are now on the AMD side, whereas the legacy side, we have nothing. You can keep a couple of VMs on the legacy side, split things up for sure, but most likely the move is ultimately going to decommission your box. But it's really whatever you want to do with it. As you can see, this is a very slow process. If you're good with that slow process, bring over a VM at a time, test it out, make sure that there's no issues before you move forward. I totally get that. If you need something a little bit faster, maybe the end of life is happening on a legacy machine, multiple clusters need to be retired so you can move forward, then AMD actually has another way to do this. And I talked with Jason Collier about a tool called VAMT, VMware Architecture Migration Tool. It's a great tool that allows you to move multiple VMs at once, even if the VM is on another cluster or machine. You can go through each cluster, put them together, then send it over to your AMD server, ultimately decommissioning several machines at once. We got Jason Collier here from AMD, and I tried to go through and go back and forth. Moving it over to AMD, the AMD side was not a problem at all. Where the problem lied was basically you brought a VM over, you had to test it, you brought another one. So if you have like thousands of VMs, this is just not going to be the best way to do this. But you guys have a tool that does that too, correct?
That is correct. We created, it's one thing, like you said, when you're moving 10 virtual machines over. It's another thing when you're moving 10,000 virtual machines. And so we created this the tool, we call it VAMT, which is the VMware Architecture Migration Tool. And it was specifically designed to help basically move from one compute architecture to another.
Okay. So how do people get VAMT? Is it something that you have to apply for, or what?
Nope. It is open source, and it is up on GitHub. So it is it's a PowerShell based system. So if you have PowerShell installed and then you install basically Power CLI, it allows you to interact with the cluster. And what we do is you set up a few parameters. We'll set up the machines you want to migrate, set those up in a CSV file, or we can do JSON for more complicated interactions. And then, you've then got the ability to go in, create this, kind of a workflow of components that you want to move, and then orchestrate the move of those over. And there's a lot of components that actually go into the way it's done, from all the way through kind of the planning phase, how it's doing the actual, it'll do snapshotting of the VMs, and then orchestrate that move over. You can even have that scheduled as well, okay, and then set up all kinds of audit components around it as well.
Yeah, and my understanding is you can also, if things go catastrophically wrong, you can always migrate back too.
Yeah, do rollback, and then it actually does have some automatic rollback components built into it. Example, if it detects that the VM doesn't come back up, say VM tools doesn't come back up on the remote side, it will actually revert that back automatically.
Okay. And it works across different platform or different servers. So if you have like 3 servers, you can move it onto the AMD without a problem, right?
Yep. Not a problem.
Okay, perfect. Well, since I have everything migrated over, we're going to use your system to show you how VAMT works, and we're going to go from soup to nuts here to try to set it up here. So let's go through the steps of VAMT. We got here's his screen right here. So go ahead and tell us a little bit about some of the setup that needs to happen before VAMT can run.
Yeah. So in this particular case, I've got my data center and I've got 2 clusters defined in here. But even prior to doing that, one of the things that you need to set up are basically tags. So we create a tag category. So you can see in this particular case, I've got this VAMT tag category set up. Mm-hmm. When you go into that tag category and you look at the actual tags, these are the tags that we fill in. Now, we've actually got some helper scripts that'll connect into your vCenter and go through and create these for you, or you can create them manually to do that. And the first thing that we're going to do in defining the virtual machines that we want to basically put into a move is we're going to tag those VMs. So I've got over here in my virtual machines folder, I've got this folder here of these different systems that I want to move over. And if I go in and take a look at this and scroll down to this tags category, you'll see that this is in a ready to migrate category. Now, if I wanted to clear that tag or assign the tag, this is where you come in and you can assign that particular tag to that VM. So we'll take all of these VMs, and you can do this on kind of a mass select level as well. You can also script this and do it in PowerShell and Power CLI. which is what I typically do when doing a mass move of these things.
Okay.
So once we've got that tagged, so all of these virtual machines in here are tagged, and you can see that these are all sitting on this particular cluster. And let's say I want to move them over to that AMD cluster. So I have also set up on here. Here is the next thing you need to do is create a CSV file of that inventory. Now, we've also got some helper scripts to do this, where we can say, hey, take this folder and create a CSV of the items that are in that. And that's exactly what I did on this. And in that, I define the machine name. So we got a VM name column. We've got the target vCenter. This is going to stay on the same vCenter, but if you want to do cross vCenter migration, that's also supported in the system. This is going to be that host pool. So this is going to be the cluster that I want to point it to. So it was on that Intel cluster, and I want to move it over to AMD. And then this is also then target port group, and then the data store. This is using, I've got a shared data store on the back end, and I'm not going to move the network, though you can orchestrate that. Like I said, you can also do JSON files where it's a more complicated setup, where you've got, say, multiple Ethernet connections, multiple data stores connected. So you can do more complex definitions and have those function in the system as well.
Okay, so if a data store is on the server, or if it's on a shared drive or anything like that, doesn't matter. You just have to direct it in the right spot.
Tell it which one to move to. And if this is a different data store than what it's currently on, it'll go through and do the storage vMotion on it as well. So It will do that. This just happens to be a shared storage system on this particular setup that I've got here.
All right, perfect. So now we have the CSV file.
Got the CSV file. Once we have the CSV file, we will define an options file, which is just a set of variables that are going to tell it what to do, basically. And this is all lined out on the GitHub side, all the options. So we've got about probably 30 different options that you can define here. Everything from, setting the schedule to, setting basically a window, like say if you've got like an outage window that you want it to go in, if there's anything specific, like, in this particular case, I'm putting it to a syslog server, but if there's any other alerting pieces, like if I want it to send an email when it kicks off or an email when it's completed, those are all things that can be put in there as options as well. But in this is a rather, kind of a simplistic version of that, where I'm going to do I'm going to do a migrate. And then I define the input path, which is pointing to just where that CSV is. Parallel task count allows you to define, how many simultaneous virtual machine moves you want to do. In this particular case, I'm defining 15. Now, there are some limitations to this, and it comes down to what VMware, they've got this very interesting way in which they do kind of a resource allocation and pull a specific subset of things that can happen. And they look at things like, are you connected via 1 gig, connection? Is it 10 gig? Is it 25 gig? And that has different weighting on how many simultaneous moves you can do. Also the storage, are you connected via, is it fiber channel storage? Is it iSCSI? Is it NFS? Is it, local vSAN based storage, and it uses that to calculate how many actual parallel tasks can be done. In this particular case, I'm putting 15 because I think I've got 11 VMs in that I want to move, and I just want to move them all. Now, you can actually, one of the really interesting things you can do with a mix of parallel task count and what you do from the CSV point of view, it will go through that CSV line by line, and that's how it's going to execute it. So if you've got an application where you don't want downtime that consists of multiple VMs, you can move the primary database VM, keep the secondary up, at the other machine, then move like a couple of front end boxes, then move the primary. And you can do that in a way where you can actually orchestrate application resiliency, right? So depending on what you do, you can get pretty kind of fancy with how you sequence it. The primary thing you need is just what vCenter server you're hooking to. And like I said, from the one of the perspectives, you can actually hook to multiple vCenter servers. In this particular case, this is all on the same one, and I'm doing from one cluster in a data center to another cluster. But if you've got separate vCenter servers, you can migrate to those as well.
Okay, perfect. And then the options file is just an options file. You could actually put this directly into the migration tool PS1, correct?
Yeah, you could. And the way that this is actually structured, which not sure how much of this you're going to be able to see really well, but here under the VMware Architecture Migration Tool, there's really just two files primarily. You got the Architecture Migration Tool, which will run, and then this is basically it modularizes out a lot of the components, this VAMT PS1. Those are the two primary PowerShell files that you need. So PowerShell file and a PowerShell modules file. Okay. And that's where most of the kind of the meat of this is. And what I'm doing in here in that options is to go through and kick this off, right? I basically just source this options file, which I'll just do from here. And then I'm already in the tool for the directory for that VMware Architecture Migration Tool. So I'm going to basically just run that and source that options file that I just ran. And this is going to go ahead and kick off that migration. Now you're going to see this is going to start going through. It looks and it's validating specific things. One of the things I've got it validating, you'll notice everything, all the tags are set correctly. It's in the ready to migrate state. And then it's starting this new batch of moves. Those are going to start kicking off. What's going to actually happen, and I'm going to switch over real quick to the VMware window.
Okay.
What you're going to see in the recent tasks, you're going to start seeing the tasks pop up where it's going to be actually snapshotting those, shutting them down, and then starting to move those over to that other cluster. And let's go ahead and switch back. This is a little more exciting. All right, so there are 11 moves in progress, 0 moves waiting to start, and the see if it's doing anything exciting yet. There we go.
There we go.
So it's initiating the guest shutdowns. It's going to do a shutdown, and it also does a storage snapshot of this as well. And in doing that, we do that for the rollback components. So okay. That will allow that kind of that full rollback piece to happen.
So in order to do this, you'd need to make sure that your data store has more than enough storage. So
yeah.
Would it be like double?
Yeah, but when it initially does that snapshot, what it's doing is basically it's more copying for any block protection. So that initial snapshot takes up 0 space. As it starts to change, the block change differentials happen, then it starts to grow. So, okay. But one thing to think about is after it does do a move, and if you were low on storage, you'll probably want to go through and remove those snapshots. You'll see these start popping up. If you notice this cluster column over here, you'll see that those are actually now starting to pop up on the AMD side, of things. So it's going through, it's orchestrating the move, it's moving it over to AMD, and it's spinning those virtual machines back up.
What happens if you have to pause a task, or is there an option to do that?
Not really so much a pause, but if there is, like I said, if there is an error in the script, it will pop up and let you know. It will flag it in a different way. These will, I'm going to switch back over to this as this is kind of coming toward the end. So there are 4 moves still in progress, but when this is done, it's going to give you a summary of what happened. Okay. And it'll say whether it completed successfully, if it completed with errors. If it errored out and did a rollback, it's going to give you kind of a complete list of this. It also, whatever directory you run this from, it creates a log directory. There'll be a VAMT logs directory in there, and you'll have a full audit of each move. And we break that down into the individual moves. There will be a full log file for each individual move for audit purposes as well. Okay. So the logging is actually pretty considerable on this. So you can see we're now at a state where this is completed. The job result is successfully moved the VMs on all of them. Target state complete. The tag state. So these will now be tagged. If I go back into VMware, you'll notice now everything is on AMD. All of these VMs are up and running. And if I go into one of these individual, you'll notice that tag changed from ready to migrate to complete. You'll also notice it's on that AMD cluster and, whatever host it's connected into.
That's amazing.
And that's it. So
yeah. In all fairness and all disclosure, we did run into a couple of problems setting this up. So there are some extra steps that do have to happen. So depending on what type of infrastructure you had, like for instance, one of the things that we ran into is on the system that I have here, I didn't have anything SSL set up. So we had to make sure that PowerShell could access without SSL enabled, little things like that. And that's where that on the GitHub, that's where that documentation is really going to come into play there.
Yeah, there's a quick start guide in there, and there are prerequisites. A lot of them are around PowerShell and kind of those prerequisite components you need around PowerShell. You need to make sure the Power CLI is set up correctly. You need to make sure you're on the right version, which we put this down to where 5.1 is kind of the required version, and that's what ships with most of the modern Windows variants out there. So we wanted it to be something where you didn't have to go download the latest PowerShell. So we wanted it to be as compatible and compliant as possible. But then Power CLI, there's always changes that are being made, and you'll see some like deprecation warnings that'll come up every once in a while. And then, just making sure like the SSL, like the SSL keys for connecting into the APIs and those things are set up. We try to hit a lot of that in the FAQ in the quick start, but that's one of those things when you do run into issues, just kind of, ping out on the GitHub and open an issue. And that's something that we can basically take a look at. So,
okay, perfect. Now this is all done. Let's say you verified everything's good. You're ready to decommission the legacy machine. We do have to do a couple extra steps here, like take the tags out, right?
Yeah, I mean, you can. You don't have to. There's nothing. Those tags aren't really doing anything other than saying, "Hey, this is completed a move." You can remove the tags, and if you did want to remove the tags on there, easiest way to do that: go in here, select all these, right click, and then you can go into tags and custom attributes, and then we can remove tags. And this will basically take, and I can say remove that complete tag, and that will remove that tag from all those VMs.
Okay. But you'll still have it set up and assigned. So if you decide to do another move to another AMD machine, you could, you have the tag ready to go, and you just have to say, add the tag.
Yeah. And those tags and the tag categories are still always, those are still in there until you delete the tag category from the tags area in vSphere. So all of those tags, they'll still be in there.
Okay, perfect. Well, Jason, that's a very straightforward. Actually, I love the fact that we don't have to sit there and move. Yeah. There's some good to doing that. Testing wise, you need to test a VM before the next one comes over. Make sure you have more than enough memory or processor or whatever inside the new machine. Then it's a great way to do it. But if you need to get it quick and dirty way done, then this VAMT tool seems to be one of the better tools here. So.
And like I said, this was a pretty small one. We only moved 11 machines over, but I think we did a test when we were kind of initially introducing the tool, but also introducing our Genoa and Bergamo-based systems where we were doing it for benchmarking purposes, and we moved something like 400 VMs. In that particular case, we did 400 VMs. Each VM took, it was like under a minute to move each individual VM, and then the whole process took like under an hour to do. When you think about that, that's a lot of virtual machines to move.
Yeah. And did you have any errors while moving it?
No, that one actually completed without errors.
Okay. But then if you do have errors, you just go back, you adjust the CSV file.
It'll all be logged, right? Yeah. And and if just as an example of one of those, if I go in that run that we just did, like here's the final report, a CSV of that final report, which is what we see down here, CSV of it. But in each individual machine, here is kind of the full log of what went on for that individual machine. You can see things like, hey, here was the start time for it and the stop time for that specific migration purposes.
Oh, that was a great little tutorial right there. Thank you very much, Jason, for your time to show us a little bit about how VAMT works and how easy it is to move everything over from one system to another.
Absolutely. Thanks, Jeff.
There you go. The machine itself loaded up quick and easy, connected to my network. I was able to create its own clusters and bring it into my environment. I was then able to move over the VMs and then, of course, move over that vCenter server, ultimately decommissioning that old legacy machine. We found out how the VAMT tool works, which is a great little tool for helping if you've got multiple clusters. Jason showed us how we can set up a cluster and move thousands of VMs over quickly, especially if you've got multiple clusters and machines. The startup times, the speed of each VM, and power needed was fairly comparable. We only had a small amount of VMs running on there at any given time. But if you have many VMs across 2 or more machines, bringing them all on one machine to run will definitely save on total cost of ownership. We didn't see any lags or bottlenecks. We did even have a power outage, which caused a little bit of confusion and concern between the transfer. It reacted fine upon reboot, and ultimately the cluster moved over without an issue. I could open them up, I could run the vCenter server onto the AMD machine, and then ultimately decommission the original machine. That does it for us here at Build Day Live. We got a lot more over at builddaylive.com or youtube.com/builddaylive. I'd like to thank AMD for the use of the hardware so we could run these test setups, set up an ESXi vCenter server, and be able to do the migration. Keep an eye out for future Build Day Live projects over at builddaylive.com, as we're going to be doing a lot more. You can also watch on LinkedIn, look for Build Day Live. That's it for me. Until next time, thanks a lot for watching. Keep building, and of course, if you've got any comments or questions, feel free to let us know down in the comments below. For Build Day Live, I'm Jeffrey Powers. Take care.